Hello everybody, so today I will be explaining to you on the tutorial questions for chapter 6. Right, so the first question, we have a graph of current against time. So this is a sinusoidal alternating current punya graph lah. So what we need to do is we have to determine the root mean square value of the current. But first, we are going to try to extract information that we can get from the graph lah. So since there are two axes, you will be able to get two information. All right. So from the y-axis, which is the current, we will get the value of peak current. So that is I naught 5 ampere. And then for the x-axis, this is a time punya axis. So we can get the period, which is gonna be 40 milliseconds, right? Yep. Okay, so next what we are going to do is we are going to try to solve for the root mean square value of the current, which is VRMS equal to, current pula. So that is IRMS equal to I naught divided by Z2. So this is 5 divided by Z2, which will give you 3.54 ampere. All right, so I hope you don't have to I hope you're not confused on how did I get 40 milliseconds here lah. Kalau kamu tengok, we can actually divide this by 2 because period is the time to complete one cycle lah. So this is one cycle, this is one cycle. So there are two cycles, 80 divided by 2 will give you 40. So that is basically here 40 milliseconds lah. All right. Okay, next, what do we need to find? We need to calculate the supply frequency, that is F lah. So how do we find F? We know that F is related to the period. So that is 1 over T, which will then give us 1 over 40 milliseconds, which will equal to 25 hertz. All right. Right, next, the change in phase for a time interval of 15 milliseconds. So the interval is 15 milliseconds. So how do we find the change in phase? So we know that based on the general equation, we know that the general equation either for voltage ataupun current. So let's just try to see it for the current lah. Current. So I is equal to I naught sine omega t, right? So from here, we know that this omega t is actually telling us the phase. So how do we calculate the change in phase? We are just gonna do it as so basically phase final minus dengan the phase initial. Okay, all right, so now this will then be 2 pi f delta t. Okay, sebab sekarang ni the only thing that's changing is the time. The angular frequency will be constant. So we can extract this omega jadi 2 pi f, and then t final minus t initial is just the delta t lah. Okay, so kita dapatlah 2 pi di sini, f is 25 hertz, and delta t is 15 milliseconds tadi. So kamu akan dapat the change in phase to be equal to 2.36 radian. Okay, so it's going to be in radian. All right, so that is question C. Next, question D. We have to do an expression for the current shown in the graph. So this is a current punya graph. So the general equation is the one that I've written here. So we're going to compare it with the general equation. So it's going to be I equal to the peak current. What is the value of the peak current? It is going to be 5. So it is 5 sine omega t. So the omega t is the one that we've calculated just now, which is 2.36 radian. Wait. Oh, sorry. No. This is this omega pula. Omega t. Okay, so it's not 2.36 radian. That is the change in phase. This is going to be 50 pi t. Okay, so how did I get 50 pi? we know that we are going to calculate omega just now, jadi 2 pi over t. So this is basically 2 divided by 40 milli. So I usually keep my pi there, so it's going to be 50 pi radian per second lah. Okay. Right, so that is the general equation for our current. All right, so that is the... Oh, wait, I forgot to include where I is in ampere and T is in seconds. All right. Okay, so yeah, this is the solution for question number 1.